Good morning, everybody. Aha. Good morning, everybody. I'm terribly sorry for a slight delay. I have a bit of a technological issue here, and it is an absolute nightmare. But obviously, it looks like that the stream is going through. So, people can hear me? Yes? I'm terribly sorry for a slight delay. And you can hear the background. So, all good. Oh, good Lord, this has been a morning, I tell you guys. This was not good. This is when the technology completely breaks down. But hey, all good fun. As long as you can hear me and see what's going on here on the screen. Loud and clear, great. There is a horrible delay in the whole thing, but never mind. So how is everybody doing? Oh yes, good point, attendance. So Moodle, please don't forget to go to Moodle and press the attendance button. So yeah, we are getting people in now. That's really great. How shall I tell you that? There is a little bit of an issue with technology in general. I don't want to say what I think about technology, but hey, so what? And I most likely have to switch to Teams. So I need to explore if I can do what I want to do. And I believe I have to discontinue the live streams on YouTube, but I will try my very best to do this sort of developing teaching where I write on the screen. I want to do that in Teams, but I have to figure out how this works. The thing why I want this developing teaching, as I call it, with the writing on the screen is, I think people are not, I'm not in love with PowerPoint. Yeah, the dreaded Teams. But hey, let's see if we get this to work. And how do people feel in general about PowerPoints? Oh yeah, I know. Unfortunately I didn't have time to delete this. But I thought, you can see the nice pimples on my forehead. Um, you like PowerPoint? Okay, good. PowerPoint's okay. Ah, okay. We talk in about 3 months' time. Uh, because then you will be all suffering from PowerPoint fatigue. Okay, so we have over 200 people, and I suggest I probably make a start. Lauren, yes, you are right. However, it seems it's not that straightforward with the screen sharing because it really depends on how you start things. And unless you have two screens, I would not be able to read your comments. Vernon is asking if the outline of all the topics are on Moodle. Yes, they are, with also links and everything. And so you should see what we are going to do in the different weeks. So what I'm going to do today, sorry, I don't want to make you feel seasick. What I want to do with you today is I want to discuss with you moles and molarity. And this is, I know, this is just a sort of a revision. And I think the biggest issue that people have, is when they see the word mole. When they see the word mole, they start to freeze. And with mole, I don't necessarily mean the animal that lives in your garden with mole. So when we talk about moles, mole is just another name for an amount. Just a technical expression for an amount. And you're all used to the expression of, let's say, a pair, a couple, so if you say a couple or a pair, that's two. Means two of a kind. A dozen is 12. A baker's dozen is, what is a baker's dozen? What's a baker's dozen? Yep, it's 13. I could tell you the story about that, why it's 13. It's just simply because, no, I'm not telling you the story. I'll let you find that out. That's 13. And a mole is just another phrase for 6.022 times 10 to the power of 23, a huge number of atoms or molecules or whatever. Well, Jody, a baker does an extra one to test. In theory, yes, but there is a slightly more sinister thing to it. But, I'm not going to tell you that. So, mole is just simply an expression for a large number of atoms or molecules or entities. And I've been asked, could you actually have a mole gummy bears? And the answer is yes, of course you can. You can have a mole of gummy bears, Haribo. I prefer the white ones. But it's a lot of gummy bears, and I think this would probably exceed the mass of the planet Earth. But never mind, mole is just an amount of, it's a large amount of a certain entity. And if we bear that in mind, and indeed it is a massive number, it's huge. But if we bear that in mind, it's just a technical phrase. We should not have any problems. Okay, there are some comments about Haribos now. That's I quite like that. And the other thing that we also need is when we are working with moles, we usually don't really have a massive concept of moles and how many molecules there are in something. And we are more familiar to work with something more that we can look at, that we can touch, that we can feel, that works for us. And we are usually more familiar with the word mass. And mass we usually measure in the unit gram. So we also can basically say that we can have work with mass and moles, and we can convert them into each other. And what we need to know is how much does actually 1 mole of a substance weigh? What is the mass of 1 mole of a substance? So what is the mass of 1 mole of a substance? And of course, this depends very much. Oh, somebody did the calculation for a gummy bear. Oh, that's great. That's a lot of gummy bears, yes. 5.86 times 10 to the power of 28 kilograms. Goodness me. That is a lot. So what is the mass of 1 mole of a substance? And of course, it depends on the substance, doesn't it? It's intuitive. But how do we find what is called the molecular mass of a substance? This is basically what this is the answer to this question. What is the mass of 1 mole of a substance? And what we are looking for is what is called the molecular mass of a substance. And if we know what the substance is composed of, we can very easily find out what the molecular mass of this substance is. How do we do that? Well, let's start simple. Let's go for a very simple substance. By the way, this is the most dangerous substance on the planet. This is, of course, water. And it is made up of 2 hydrogens and 1 oxygen. And we can very easily look. No, the lecture at 3 will be actually still on YouTube. Sorry, I just saw this comment. This afternoon, the BI 300. I can't switch that quickly. So we know that hydrogen has one proton and nothing else. So when we look at the elements in the periodic table, we can easily find out what is the mass of an element, because this is the number up here. And usually an element is always given in the periodic table by two numbers. Let's write that for oxygen. So oxygen would be 8, 16. 8 means it has 8 protons. That's the number of protons. And 16, that's the mass. The total mass, which is composed of the number of protons plus the number of neutrons. So in this case, we see that oxygen has 8 protons plus 8 neutrons, and that gives us a relative molecular mass of 16. So we have a relative molecular mass of 16. Relative means in this case it is relative to a sort of a defined fixed point, and this fixed point is 1/12 of the mass of carbon. And we need to be careful here because carbon can have different masses, and we are talking about the isotope carbon 12-6. So that's relative. But what it actually means, it is just simply tells us, when we are looking at that, it tells us that 1 mole of oxygen, of O, and I write it like that, is the equivalent to 16 gram. Now we know that oxygen doesn't come like a single O, it comes as O2, but let's not worry about that. So we can easily determine the molecular mass for water, H2O, and each hydrogen is equivalent to 1. Oxygen is 16, and for the hydrogen we have 2. So the molecular mass for water would be 2 times 1 plus 16 equals 16. That's the relative molecular mass. That's the relative molecular mass. And we can put a unit to it, and we can just simply say this 16 is also, that stands for 16 gram per mole. So water has a molecular mass of 16 gram per mole. Does that make sense? That's the easiest way. And you are absolutely right, that is 18. At least somebody is awake. Thank you very much, that's 18. That was just to check whether you are paying attention. Good. Yep. You're tired today. Yes, I am tired. You're absolutely right, because last night I was thinking about how to convert everything to teams. Anyway, so we have 18 gram per mole. Okay, here's one for you guys. I want to know the molecular mass of glucose. Yes, Lucy, absolutely right. We add up the masses of the atoms. We get a dimensionless number, 16 or 18 or something like that. But we can think of it as there is the unit of gram per mole in it, because that is what the number tells us. So molecular mass of glucose. Glucose is a carbohydrate. And some people have already done that. So we can write glucose as CH2 6. This is actually where the name carbohydrate comes from. Carbohydrate. And in glucose we have C6H12O6. And we would find we have 6 times 12. We have 12 times 1. That's the hydrogen. And we have 6 times 16. And if we add them up, we get 180. So the MR, that's the relative molecular mass, would be 180, and with units the molecular mass, which is very often written like that, would be 180 gram per mole. Okay, happy with that? Well, you see, Bernardo, that is where the expression carbohydrate comes from. So the unit for MR, it's the relative molecular mass relative to the carbon 12. MR doesn't have a unit, is unitless. There's no unit in it, in the relative molecular mass. The unit for molecular mass or molar mass, or some people call it molecular weight or something like that, is gram per mole. But these differences are really, I would say, sort of semantic. It's not really of huge significance. As long as you know what to do with it, that's far more important. Okay, so now let's play around with this concept of molecular mass a little bit and molecular weight. Let's say I have 0.3 mole of glucose. And we know glucose has a molecular mass of 180 gram per mole. We have 0.3 mole of glucose. How many atoms is that? How many atoms do we have in 0.3 mole of glucose? Shimek says 1.81. How did you do that? Well, what you did probably was 0.3 times 6.022 times 10 to the power of 23. So we just multiplied the mole with the number of atoms in a mole, and we get 1.81 times 10 to the 23 atoms. Or we probably should not say atoms. I should not call it atoms. We should say molecules, because the atoms or the molecule is made up of the three atoms: hydrogen, carbon, and oxygen. So we should say molecules here. Okay? That makes sense? Fantastic. We don't have to worry. But now, I mean, to be perfectly honest, I don't give a flying flamingo how many molecules are in 0.3 mole. I want to know how much is that in grams. So 0.3 mole in grams. How much is that? And I need to find out a way how I can convert that. Now you probably have learned different ways of converting it. And some people already come in with the answers. Let's go through it, because if you can do that, then you understand the concept. So we are looking for 0.3 mole of glucose in grams. How many grams is that? And we have a molecular mass equals 180 gram per mole. Oops. Oh, that's cool. Make something funny here. Ha! And that was not what I wanted. Good. Now we are back. Good. How many are there in mole? That's a good question. We are talking about atoms when we have individual atoms. But in the case of glucose, we actually have the atoms joined together to form a molecule. So for the sticklers here, we would call this molecule instead of atoms. But again, it's a sort of a semantic difference here. So, how did you learn to do that at school? How to convert mole into grams? I have seen 4 different ways that people do that. One way is what is called the first principles. The way of first principles, or the rule of threes. Rule of threes. And that is probably a fairly intuitive one, but you need to be familiar and confident with a fantastic Fantastic. You need to work with fractions. And people in the comment section have given basically all of the answers. There are very different ways of dealing with it. Grandma moles. Yes. So let me show you the first principle. Because with first principles you can basically do anything, but it is quite long-winded. So what you say is 1 mole of glucose is the equivalent, and I write equivalent like that with this double arrow. 1 mole of glucose is the equivalent to 180 grams. Right? That is what the molecular mass tells me. I can also write it as 180 grams is the equivalent of 1 mole. Both ways are absolutely valid. And I'm absolutely fine with either way. Question, can we use relative molecular mass and molecular mass interchangeably? Yes and no. In common calculations, you will find it doesn't make any difference. But relative molecular mass has no unit, whereas molecular mass, without the relative, has the unit gram per mole. And that's quite important, okay? As we will see. So coming back to first principles, so we say 1 mole is the equivalent of 180 grams, but I don't have 1 mole, I have 0.3 mole. And I want to know how many grams this is. And I've written it like that so that you can immediately see what I'm going to do, because that's really clever. So what I can do, the way I've written it, is I just simply do this. And I convert that, my expression, into fractions. So I have 1 mole over 0.3 mole equals 180 grams divided by X. Okay, and now what we need to do is we need to find X. And if you think about it, all we need to do is we need to bring the X to that side and all the other stuff to the other side. And we know how we do that. It's just simple maths. And we get X equals 180 grams times 0.3 mole divided by 1 mole. So that would be our equation. We do cross multiplication. Absolutely right. And what we see is something incredibly reassuring for us. What happens to the moles? Now, the moles cancel each other out. And what is the unit that we have left? What's the unit that's left? Of course, that's the unit that's left. That's grams. And that is exactly what we wanted, isn't it? We wanted grams. Absolutely right. So all we need to do is we now need to do the calculation. So x equals 180 grams times 0.3. And that gives us 54 grams. So if I want to have 0.3 moles of sugar, of glucose in my coffee, which I desperately need, then I know that I have to put in 54 grams of sugar in my coffee, which makes it quite sweet, but hopefully is a little bit of brain food. So that is the concept of first principles. And it's basically the rule of three because you have 3 steps in it. You might be interested to hear that this was the height of mathematical sophistication in the 16 and 1700s, at least in France, where I know that if you were able to do this rule of threes in any calculations, you did not have to worry about any jobs. This was, you know, wow, that person can do the rule of threes. Basically, they can do anything. They are perfect accountants. They can work whatever. So this was your entry to jobs. Doing the rule of threes has changed a little bit now. People said they also used the equation for doing that. So let's go back. We want to see 0.3 mole. How many grams do we have for that? That was our question. Let's do the second one. And the second approach would be with an equation. And people said they learned equations for that. And the equation for that would be the mass equals molecular mass times the number of moles. So that's the equation for it. Cheers, Hassan. But you're right. So mass, that's what we're looking for. Molecular mass, we said it's 180 gram per mole. And here you see, this is important that molecular mass, here, this has a unit. If you did it with the relative molecular mass, which doesn't have a unit, which is linked to the carbon stuff, you would run a little bit into a problem. But when you say molecular mass, it's 180 gram per mole, time the number of moles, that is 0.3 mole, and the mole cancel out, and we get the same thing, it is 54 grams with the equation method. So you see the equation method is much faster. The downside is you have to remember this equation. Remember the equation. And that's a pain. I don't like to remember things. I always run into trouble because I can't remember my wife's birthday. The third method that people said is the triangle method. Who has done the triangle method? Who is doing the triangle method? Yep, lots of people do the triangle method because it's quite convenient. But in a way, it's just a modification of the equation. So in the triangle method, you would write the mass on top. You would write the number of moles. That's the number of moles. And here you would write the molecular mass. You would write that in this sector. And now, depending on what you're looking for, you just simply remove that, what you're looking for. So in this case, you're looking for the mass. So you take that out. And you just simply write down what's left of the triangle. And you have the number of moles times the molecular mass. So mass is equal to mole times molecular mass. And that was 0.3 times 180 gram per mole. And here you've got mole, and you end up with 54 grams. Yoo-hoo, we got our 54 grams. Great method. Wonderful. And it's very easy to understand, and that's why it's taught at school. The downside is you need to remember, as I think somebody said earlier, you need to remember where to put things. This is the big problem. I can't remember things. Which sector do I need to put things? And that is why my favorite thing is something different. And somebody mentioned it earlier. This method is called dimensional analysis. Or also referred to as unit analysis. Yes, I am using the units. Instead of remembering anything, I let myself be guided by units. And units are absolutely essential. A number without a unit is, how shall I say, university without students. It's a joke. It doesn't exist. No, it's like, Christmas without turkey. It is going to a party without... Okay, you finish the sentence, right? So, how does it work? Let's write down. We want to find the number of amount of grams in 0.3 mole, and the molecular mass is 180 gram per mole. Okay? So, the first question is, what am I looking for? I am looking for grams. So I write down grams. That's really important. And now I am guided by the units. So in my givens that I have here, these are my givens. I need to arrange the givens through multiplication and division in such a way that at the end I have the unit gram left, nothing else. Okay? So, in my givens, do I have the amount of grams? Do I have the unit of grams anywhere in my givens? And the answer is yes, I've got grams in here. So what I'm going to do is I write down 180 grams per mole. And what I see is that the grams are in the right position. I have the gram here. So my grams are there, and it's in the grams per mole. All I need to do now is I have this pesky mole here, down here in the denominator. Now I need to get rid of this mole thingy. How can I do that? Well, do I have mole somewhere else in my givens? Yes, of course, I've got mole in here. So what I can do is I can multiply the whole thing by 0.3 mole, because what I see is if I multiply that, then the moles cancel out. Boom! Bernardo, absolutely right, yes. That's so easy, isn't it? I don't really have to remember anything. I'm guided by the units. So what have I got left? What unit is left? The only unit that is left is this gram here. How cool is that? 180 grams times 0.3. And because I've got the right unit left, I can stop. There's nothing else to do. So I've got 180 grams times 0.3, and that gives me 54 grams. What I need to be careful with is I need to have the right units always there. If you make a mess of the units, you are royally fluffed. You can also use it in exactly the other way round. Let's say we have 36 grams and we want to find the number of moles in 36 grams, and we've got 180 gram per mole. Let's quickly do that with this dimensional analysis. So I want to find the number of moles that are in 36 grams. What am I looking for? What's the unit that I'm looking for? What's the unit that I'm looking for? Absolutely right. I'm looking for mole. So let's write this down. Mole. Now, do I have mole anywhere in my given? Do I have mole anywhere in my given? Yes, I have it. I have it here. But you see a big problem. If I write it as 180 gram per mole, the issue is the mole is in the denominator. But we want it in the numerator. So what we can do is we can just simply say what we need to do is we write it the other way around. We know that 180 gram is the equivalent of 1 mole, or 1 mole is the equivalent of 180 gram. So we write it as 1 mole divided by 180 grams. Now I've got my mole in the numerator where I want it. So the mole is here in the numerator. So the moles are in the right place here. All I need to do is now get rid of this pesky gram here. What do I need to do in order to get rid of the grams? Well, I need to multiply it so that the grams cancel out. Do we have grams anywhere? Yes, we've got grams here. So all we need to do is we multiply by this 36 grams. What we see is that the units cancel each other out. Hasta la vista. Baby, I'll be back. So, what have we got? We have 36 mole divided by 180. And that gives me 0.2 mole. Does that make sense? Now, a lot of people ask me, which method should I use? What method should I use when I do calculations? And people say, I understand this method, but I prefer the triangle. I honestly don't care. If you use first principles, if you use an equation, if you use a triangle, if you use dimensional or unit analysis, I seriously don't care about it as long as you get the right result. And not just the right number. If you give me 0.2 as the answer, by default, this is wrong. Because I told you, whatever number you come up with, it has to have a unit. So it has to have 0.2 mole. How you got to this 0.2 mole, I seriously don't care. As long as it's right, absolutely fine with me. I used to do everything from first principles because that is how it made sense to me. And then I came across this dimensional analysis and I thought that's actually quite cool. And it helps me when I have to do more complicated things. And tomorrow, when we are looking at how to make up solutions, we will run into a case where we not just have two givens like we had here, like this one here and this one here. We will have more than two givens. And then with equations and the triangle method, it gets a little bit more interesting. But with the dimensional analysis, it is just simply a breeze. You write it out. I don't have any shares in dimensional analysis, but I think it's cool. With that, I think I better stop now. Thank you very much. At 3 o'clock today, we are going to have a BI 300 session. But if you're not doing BI 300, don't worry about it. It will still be on a YouTube live stream. And I hope over the weekend I will have developed the technologies to do everything on the dreaded MS Teams. If you have any questions, put them in the group chat or email me or whatever means. But thank you very much for listening and working with me, and I thoroughly enjoyed it. Thank you.